Hello everyone, welcome back. In this lesson, we're going to start to unpack the syntax of P5.js, and we're also going to be talking about the basic shapes and drawing shapes that we can do, and also talk about how colors are handled within P5. Okay. So let's get started. So I have in front of me here a new sketch that I created in the P5 editor. The first thing I'm going to do is give this sketch a meaningful name. So this is the randomly generated default name. We are going to change this to something a little bit more meaningful. Let's call this a shapes colors. Yep. All right. So that's going to be something you want to do as the very first step when you create a new program. Just make sure you give it a useful name and then of course save it. Until you save it, it's actually not going to be part of your collection of sketches, right? Your sketches over here. So once you've done this, then you can, as you code, you can hit Control S to save your work. But this is a really important first step. Okay. So in this lesson, we're going to talk about shapes, colors, and the coordinate system. How does that work in P5? And as we do this, we're also going to unpack a lot of the very basic syntax elements of writing these lines of code, right? What all do these parentheses, commas, semicolons, curly brackets mean? Okay. All right, so let's start with the curly brackets. As we've mentioned in the previous video, curly brackets are going to be ubiquitous when we program in JavaScript. And they're used to indicate sections of our code, right? Code blocks is how I like to think of it. We're going to always have a matching open and closed curly brackets. So currently in our program, we have the two default sections. We have setup and draw. These are called functions in JavaScript. And we'll see down the road, we'll start to create our own functions and we'll add to this. But for now, our first few weeks, the basic programs are only going to have these default functions. And the way that these code sections are delimited is using the curly brackets. So setup begins here and ends there, and draw begins here and ends over here. And as we introduce new programming concepts, we kind of really brushed onto one in the previous video. We used something called an if statement. We'll explore those more next week. These sections, these subsections of our program are also going to be delimited, always using curly brackets. So we're going to use them for different things, but they're always going to generally mean the same thing. It's going to mean here's a section of code that I want to identify. All right. The actual syntax of the function over here, we are going to skip over that today. We'll dive into this a little bit more once we learn how to write our own functions. So for now, we're going to just move over that part, but these are always created for us when we create a new sketch. We're going to have a function called setup and a function called draw. And as you remember, setup, its job is to run once in the beginning, and draw is going to follow setup and then run over and over until we stop the sketch. Okay. The next little bit of syntax I want to introduce is the idea of a comment. So comments in programming are really helpful. There's a few ways we can create comments. The basic way is we're going to start a line with 2 forward slashes. So we'll say setup runs once in the beginning, and then draw, our main loop, runs over and over. Okay. So comments are used to basically put notes in your code. They're going to be grayed out automatically once you start to put in the double slashes. And you can just put whatever you want in comments, text, other code, right? And the purpose of the comments is to allow you to start to annotate what's happening. Both for the purpose of, if somebody else reads your code, you can explain what you're trying to do using comments. It can also be helpful for yourself, give yourself notes so that if you open your program later on, the comments will help you kind of find your way again about, what was I was trying to do with this code? What are things doing? You can use comments to basically pepper your code with some explanations of what's happening. I'll be using comments heavily in the examples that I share with you this semester, just to kind of explain what all the lines of code are doing. Okay, so we can see here, this is like, I can add a comment, this is our drawing surface, and we'll do as we did in the previous example. We're going to move from having it 400 to 400. I like to kind of take up all the room here. So we're going to use what's called a variable, and we'll explain variables in more detail next week. But for now, we're going to use this variable called window width and window height. And variables are basically names that refer to values. These are built-in variables, which mean they kind of come with P5. We don't have to define them or create them. And these two particular variables always refer to the dimensions of our canvas, the dimension of the HTML window that our canvas is within. So comments we can use to add some notes into our code, right? So you can use comments wherever, and because they're grayed out, they're just ignored by the program. So they're not actually part of the code. Whatever you put in a comment is going to get ignored, and the other lines is really what makes up our program. You can also write longer comments. You'll sometimes see this if you use the / and a star, and then the star and a /. This is a multi-line comment, right? So you can everything you put in between these is going to be considered the comment. I'm not going to use these so much, but it's good to point out because you might run into them sometimes. And if you'll see what that means if you run into this in somebody else's code. The other thing you can do to add a comment or turn a line of code into a comment is to use control / So I did that. You cannot see my keyboard, but if your cursor is on a line that isn't a comment, you do control and the /, it will turn it into a comment. And you can undo that by doing the same thing. So you can toggle between lines being a comment or not. This is helpful because sometimes you're going to want to take out a line of code from your program and not necessarily delete it. Maybe you want to put it back in later. You just want to see what's going to happen if you take it out. So this is called commenting out a line of code, and you can do that easily, right? I've turned this line into a comment. Now there's no longer the gray background. This doesn't happen anymore, and I can put it back by uncommenting. Also worth noting, because I won't point this out every time, but because we're only just getting started, I don't have to hit the play button every time I'm making changes here because I have this auto refresh box checked. If I don't have this checked and I comment it out, nothing happens because I would have to hit play again to rerun the sketch. I find when you're learning in the beginning, it's very helpful to tick that auto refresh box. There may be scenarios down the road where you don't necessarily want to continuously run everything every time you make a change. For example, maybe you're loading a whole bunch of files and assets and it's going to take a while. It might be irritating to have your sketch auto restart every time you change something here. But in the beginning, we're going to write these tiny little programs, and being able to see the changes you're doing right away is very, very helpful. Okay. All right. So those were comments, right? So moving on from that, the other bit of syntax I want to unpack is how we write these lines of code. Now, you may have noticed I'm following a very particular pattern for both of these lines of code, right? I have a word here which turns this kind of blue color and gets bolded when I have the correct terminology. This highlights that I'm using a command or a function that's part of the P5 set of functions. We'll open the reference in a little bit, and I'll show you all the possible functions that we can use. Then we have parentheses, right, which open and close, and then inside the parentheses we have what's called arguments or parameters. So I'll use these two words interchangeably, and these are separated with commas. Okay? So this is a function. So here I have a function called create canvas. It has a particular job. When I call it, it's going to create my canvas element and give it a size. And the parameters are the things that you can use to tell the function exactly what you want it to do. So you're going to provide these when you run the function. So here I want the function to create a canvas that has the window width and the window height. So some functions will take 1 parameter, 4 parameters, 0 parameters, and in a minute we'll jump to the reference. The reference is basically your dictionary for P5, and it has a catalog of all the different functions you can use, what parameters they require, in what order, and so forth. But the important part here is just the overall syntax. So most lines of code are going to follow this pattern. We're going to have the name of a function we're calling, then we're going to have parentheses, and in between the parentheses we'll put parameters. And then at the end of the function over of the line, we have a curly bracket character. Sorry, a semicolon character. Now the semicolon is really interesting in JavaScript. It's technically optional, so I can take these out and my code still does something. It still runs. Okay? But the semicolon is in most other languages required as kind of the dot at the end of the sentence. So a lot of the lines of code are going to end with a semicolon. It's a good habit to get into to put them in. The reason for that, even though I just said in JavaScript they're optional, there are some very pointy edge cases where JavaScript will require you to have a semicolon in a particular place in order for the code to run the way you would expect it to. We're not going to dive into that right now. But more importantly, a lot of other languages you're going to run into, specifically, next year when we start to learn about Arduinos and the C programming language. In C, you always have to put a semicolon at the end of your lines. In Java, you have to do that as well. So it's a good habit to just get into the habit of putting these in, even though technically if you forget one, you're not going to get any errors and the code is still going to run. Okay? So think of the semicolon as the dot at the end of your line of code that says, I'm done. There will be exceptions to that, mostly when it comes to the structural pieces of the program. Like notice this doesn't have a semicolon, this doesn't have a semicolon. This is going to apply mostly to the lines where we either call a function, declare variables, do some math on some variables, and so forth. So kind of the meat and potatoes of our program, we delimitate these lines of codes using semicolons. And even though they're optional in JavaScript, in this class anyway, we're going to get in the habit of using them just to set us up for good habits in the future when we learn other programming languages like C. Okay. All right. Okay. Now, let's talk about this number over here, 220. So in P5, we're going to have the option a lot of times to set colors because a lot of what we're going to be doing is drawing stuff in the canvas. And 220 here, counterintuitively, is a color. It's represented by a number. It's a number between 0 and 255, where 0 is black and 255 is white. Okay? So a single number represents a gray value, essentially. If I put this down to 0, I'm going to get a black background. If I put this up to 255, I'm going to get a white background. And something in between is going to give me a gray. Okay? That's one way we can specify colors. In P5, you can also use color names, and we're going to put the names inside quotes. We can use either double quotes or single quotes. Okay? And when I put a quote, the editor automatically puts the matching quote at the end for me, which is convenient. And here we can use HTML color names. So for example, I could do gray, I could do blue, I could do turquoise, right? Oh, that's not an actual color name. Okay, let's try orange. All right, that works. Let's go back to gray. HTML color names, there's a list. If you just Google it, you can find it over here. So all of these are valid names that you can use as colors in P5, okay? And there's a number of them. So that's one way that you can specify colors. The other way is you can also use this notation, which is the HTML sort of hexadecimal color notation with the pound sign. So you can also do that in P5, like so. You will have to put that one into quotes as well. Okay, so this is the sky blue, light sky blue. Okay, so I could use the name of the color. I could use this notation. So there's many different ways we can enter in colors. You can also directly enter red, green, and blue components. So a single number is a gray value. If you put in 3 numbers, it becomes an RGB for red, green, and blue color. So for example, bright red would be 255, 0, and 0. Okay? And there's a few other ways as well. And this is where the reference becomes very handy. Okay? Let's get rid of this very angry red here. So this is where the reference becomes very handy. Let's open it here for a second and close this tab. So the reference is your best friend when you're learning how to program in P5. It's basically a page that's going to document all the built-in variables and all the functions that are part of the, let's call it the P5 language. Okay, P5 is not really a programming language. It's a library for JavaScript, but it kind of gives you a set of tools that you can use to then make things happen in the browser very quickly. So when we're dealing with colors here, see, we're using the background command right now. So background is part of the reference. Okay, and we can click on any of those commands, and we're going to get some very helpful examples, right? This is showing us here all the different ways we can set the background color. This is using RGB colors, right? This is changing the color mode to use hue, saturation, brightness. We'll talk about these types of functions a little bit later in this video. Color names, and so forth. Okay? So you don't have to remember all of those things when you're programming. You just need to have the reference handy so that you can look it up if you're not sure what parameters go into what functions, what are the things I'm allowed to do, how do I need to structure my syntax so that it works. The reference is your friend. Okay? And one of the reasons we use P5 in this course is that a lot of time has been put in creating a very helpful reference for beginners in P5. Not every programming language or environment is as forgiving on the beginner as P5 is. So this is a very friendly place, this reference, and it's full of useful examples, detailed explanations, and so on and so forth. So we'll try to go back to this reference when appropriate as we introduce new commands to show you where you can look them up. But you can always find it inside the help menu here. You can always bring up the reference. All it is just this reference page on the P5JS website. All right, so we can see the background color here. There's lots of different ways that we can set the color. Let's just go with a boring gray for now, just because it's easy on my eyes. All right. Okay, so let's introduce some new commands. We're going to talk about shapes and the different ways that we can draw stuff in the window in P5. So we're going to start with the humble point. Okay? So let's draw a point here. I'm going to put in 100 and 100. So notice the syntax I'm following, right? I'm using the name of the function I want to use, the point function. I'm opening parentheses. Then I'm putting in my arguments. In this case, point takes two arguments, an x and a y coordinate. I'm going to put it on top here using a comment so we can quickly see what those numbers represent. And I've given it an x coordinate of 100 and a y coordinate of 100. I close the parenthesis, and then I put my semicolon at the end, the dot at the end of the sentence. And what that triggered is this little dude over here. Now, this is not a speck of dust on your monitor. This is actually a point in the canvas. We can see if I comment it out, it disappears. Okay? So point simply colors a single pixel. Okay? It uses the stroke color. So whatever we set the stroke color to do that, we have functions called stroke that will allow us to set the stroke color. And we'll see when we do other shapes, we also have a fill function that will allow us to set the fill color. Okay, so now I have a white stroke, I have a white point. Comment this out. All right, so these coordinates here, x and y, I'm sure most of you have run into the concept of coordinates before if you've done high school geometry. But let's go over what these coordinates mean really quickly here. X here refers to a position along what's called the x-axis. So the x-axis runs left to right or horizontally, and then the y-axis runs this way, up and down vertically. Okay? However, the one thing that's really important to point out in P5 that is counterintuitive when you first get started is the position, first of all, of what's called the origin. So the origin, which is the 0, 0 point in our coordinate system, by default is always going to be up here in the top left corner. So 0, 0 is where my mouse cursor is pointing out over here. And then the coordinates increase along the x-axis when we go to the right. Okay? So coordinates increase along the x, and they also increase along the y-axis as you go down. Okay? So if 0 is over here, right, 100 on the y-axis is down here. This is counterintuitive because if you've done high school geometry, you would have a coordinate system that is the opposite of that. So you would have a 0, 0 oftentimes was in the middle, and then a positive coordinates on the y-axis would take you in the up direction. In P5, this relationship is flipped. So positive y moves you down in the window. Okay? You can also, of course, have negative coordinates In this case, because our origin is up here in the corner, if I draw something with a negative coordinate, it's going to be off canvas, off screen, we won't see it. But down the road, we'll see we can move this origin wherever we want, and we'll be able to draw things with negative y and negative x coordinate if we want to. So if I change this coordinate to 200, right, I'm just moving my point down over here. So now I have 100 on the x, 200 on the y. So whenever we draw things inside our window, we're going to have to start to get to know this coordinate system really well, because we are going to be always defining positions in terms of their pixel coordinate and their dimensions based on their size in pixels. Okay? And just to be clear, a pixel, right, is a single point in my screen. This is basically just the tiniest unit that we can draw in the screen is a pixel. Okay, so we have point as one of our common drawing functions. Let's move that guy even further down here. My point here about 400. The next one in line, no pun intended, is the line function. Okay? Now a line in P5, see I've just put in line, I'm going to get an error, expects 4 arguments. Okay? So what does that mean? Well, it means that if a point is a single coordinate, a line is a pair of coordinates. Okay? It's a start and an end point. So for example, I could have a line that starts at 200, 400. That's going to be, let's say, about here. And I'm going to have that line end up here. I'm just kind of making up these coordinates here on the fly, just so we can see something happen. All right, so here's a line, right? So my line starts at 200, 400, and ends at 300, 200. So this is a line. It's 4 numbers, but what these numbers mean really depends on where I'm putting them as arguments. And just to highlight that with a comment, we're going to say a line is x1, y1, x2, y2. Okay? So it's a pair of coordinates. The first 2 numbers are one coordinate, the last 2 numbers are another coordinate. So we can draw lines, we can draw points, and these are affected by the whatever stroke color we decide to place. Okay? Now you'll notice once I call stroke here, the point is white and the light is white as well. So once you use stroke, everything that comes afterwards in the program is going to use whatever stroke color you've enabled. Okay? If we want to change that, all we have to do is call stroke again. So if I wanted my point to be white and my line to be black, I would call stroke here to set the white point. Then I would set back, I would revert back to a black stroke using stroke again, and then draw the line. Okay? So this highlights the sequential nature of the program. So typically the programs that we're going to write, right, instructions going to run one after the other, following the order in which we've written them, and of course taking into account the overall program structure. So in this particular program here, we start into setup, we run create canvas once in the beginning, and then the code jumps into this section, and then over and over repeats these 5 lines of code that we've written in that order. Okay? So the order of operations is going to become something you really have to get used to, and it's very important because as we start to draw some other shapes, you'll see that things get drawn first based on the order that they come in the program. Okay? And then when I change the stroke, same thing. You don't have to do this for every shape. You'll see that the next shape that I draw is still going to have a black stroke. So once you change the colors, right, these are sort of in effect until further notice, until you specify otherwise. And which shapes are affected depends on where they're placed in the sequence that you're writing. Okay. So we have a point and a line. We also have all the other basic geometric shapes that you can expect, and we'll explore those really quickly here. If I go into the reference over here, we have different shapes. These are called the 2D primitives. We have arc, ellipse, circle, line, point, quad, rectangle, square, triangle. Okay, we won't do all of them, but we're going to do a circle and a rectangle just to explain some of the concepts relating to that. And for your exercise this week, you can go and explore them as you see fit. Okay? Use the reference to kind of help you along. So for example, if I wanted to learn how to draw a circle, I would click on the circle command reference. It would show me here. This draws a circle at a location, 30, 30, with a certain diameter, 20. And all of these are in units of pixels. Okay? So let's try this out in our program. we're going to draw a circle. I'm going to try to move it over here, 400, 400, and it's going to have 200 pixels in diameter. Okay, beautiful. This is not my best work, by the way, but I'm not trying to make something mind-blowing here. I'm just trying to walk you through the different functions that we can use, and as we do so, we'll get a little familiar with the syntax. Okay? Notice I'm always following the same recipe: function name, open parenthesis, parameters, commas in between, close parentheses, semicolon. And we can tweak these numbers, and because we have auto refresh on, we can immediately see the impact of what we're doing. Okay, could shift it over a bit, move it by 420 on the x-axis, okay? And you'll notice both of these have a black stroke because I've set the stroke to black here. Therefore, the line and the circle both have a black stroke. I could decide I don't want a stroke around my circle, and I could do this by using a function called noStroke. Okay, so noStroke is interesting because it doesn't have any parameters. Okay, so we haven't seen that yet. noStroke is a function that doesn't have any parameters, but I still need to put in parentheses when I write it. So whether or not a function takes parameters or arguments in it, doesn't matter. You still have to put the parentheses. This is the syntax that essentially tells P5, this thing here is a function or a command. Okay? And this is going to distinguish it from other types of lines of code. For example, we'll have variables, which we'll talk about next week. Variables are also going to be keywords, right, like this, but they're not going to have the parentheses. Therefore, they're not going to be interpreted as functions. So noStroke simply says, from now on, turn off the stroke, just keep the fill. And of course, there is the equivalent. We can say no fill, right? So no fill is the opposite. Here I just have the stroke and I don't have a fill inside. Or I could say no stroke and then set a fill color using the fill command for my circle. Now for the color name here, we could do whatever. No, I'm going to draw a pink circle. There we go. And remember those color names, you can just Google HTML color names. You'll see a list of names that you can use. And you can, if you want, you can use RGB values. You can use gray levels. You can use HTML color codes, whatever you prefer. Okay? All right. Let's leave the stroke here for now. I'm going to leave the black stroke. Another command we can use to draw is called rect. So rect is short for rectangle. A rectangle wants to have at least 3 arguments. Some commands will have a variable number of arguments. We'll see that in a second. But just to demonstrate here, I'm going to draw a rectangle right on top of my circle. So using the same coordinate, 420 and 400. Okay, so same coordinate and same size. Okay. So this is the diameter. If you draw a rectangle with just one dimension, it becomes a square. Okay, so this is a nice shortcut. But here you're going to notice something interesting happens. So my circle, right, the coordinate I used to draw it was the center of the circle. Whereas in the case of the rectangle, the coordinate was in fact the top left corner. So this is the default behavior for both of these shapes in P5. We're going to think of this as the circle mode, right? The circle mode has a center coordinate by default, and the rectangle mode has a corner coordinate by default. Okay, so this is the same coordinate, but it changes how the shape is being drawn. And this is something that we can change as we see fit, as we draw our code, as we write our program. The way we change this in P5 is we have a command called rectMode. Okay? And the parameter for rectMode is going to be a word. Okay? So by default, rectMode is center. So the way that we specify this is all caps. We write center. This one doesn't have quotes. Okay, so it doesn't have quotes like this. It refers to a built-in keyword in the language, just like window width and window height, except it's in all caps. And center means the coordinate for the rectangle is going to be center over here. Right? Let's see. What happened to? Oh yeah, my circle is behind it now. Let's make it a little bit bigger. It's like, what happened to my circle? There we go. And set a different fill color for the box here. Let's make it orange. I love orange. So we can change the behavior of each of them. Similarly, we could change the circle mode. Nice circle mode. Is there a circle mode? No, there isn't a circle mode. It's called ellipse mode. So ellipse covers both the ellipse command and the circle command. By default, it is centered, but we could change it to corner. We could make it behave like the same way the rectangle was behaved. So now we can imagine an invisible box around this ellipse, and this is the coordinate we're giving to draw it. So these mode commands, they basically alter what's going to happen after them. Okay? So if I set the center mode here, or the corner mode, right, it changes the way P5 is going to interpret my rectangle commands. Okay? Now, why would you want one over the other? It depends on what you're trying to do. Sometimes it's convenient to have the coordinate of your box be the corner over here. Sometimes it's convenient to have the center be the coordinate that you specify. Okay? If you want to line things up, for example, knowing that you can change the mode that you draw these rectangles can be pretty useful. Now, talking about syntax here, another bit that I want to emphasize is the the spelling of these particular commands over here. So you'll notice here I have rectMode and I have an uppercase, and I think we've used that before, but I haven't mentioned it. We have create canvas, uppercase C. Okay, so this is all lowercase. Then we run into an uppercase M, right? And this is a kind of a naming convention you're going to see throughout P5.js. The idea is that there's basically two schools of thought in programming when it comes to naming functions. These are kind of two different words, right? So by putting an uppercase M here, it makes it a little bit easier to read. If this was lowercase, right, this becomes a bit more of a mush, and it's a little bit harder to parse visually. Oftentimes, the other strategies people will employ is put an underscore to separate the names, the two names. Okay, but in P5, they don't do that. They use the uppercase method. Okay? So every word are stuck together, but the beginning of each word is turned into an uppercase letter. Similarly here, this is all uppercase, and this is important. If I put corner, all lowercase, I'm going to get these errors down here. Here is telling me corner is not defined. What that points to is the fact that in JavaScript, case is important. It's a case-sensitive language, which means uppercase and lowercase are completely different things. This is good to know because we have to follow whatever things have been defined as in the reference, right? Or in our own code. Eventually, we're going to start to create our own commands, our own keywords, our own variables. So whatever we decide or whatever has been defined, we just have to follow it. It means that even though it reads the same to us, if the spelling is uppercase and you write it lowercase, as far as P5 is concerned or JavaScript, they're completely different words. Okay? So it is sensitive to the idea of case. Same thing here. If I put rectMode with a lowercase m, I get an error. It's saying rectMode is not defined. Now, thankfully, P5 has some very helpful messages, right? It's saying, oh, maybe you accidentally wrote rectMode when you meant rectMode, capital M, right? So these are different symbols as far as the code is concerned. This takes a little bit of getting used to when you're starting out a program, starting to learn programming. But eventually this is going to become second nature. Okay? These conventions will become second nature, and you'll get used to the idea that the case that you're using to write things actually matters. Okay? So if something is meant to be written uppercase versus using this particular arrangement of letters, it just means that these are going to be different symbols to the language, and you just have to basically follow the rules, whatever it's been defined as. So oftentimes the all caps syntax is going to be used to refer to what's called constants. So these are keywords that are just things that never change. So the corner mode is just refers to a concept that doesn't change, whereas window width and window height, they're not all caps because their values will change as you refresh, as you change the size of the window. Okay? So we'll come back to that idea of constant a little bit more next week when we introduce variables. Okay, so I think we've covered a lot of the basics here when it comes to drawing. Of course, like I said, we have circles and rectangles, but there's all these other shapes that you can use to draw the basic 2D primitives, and then these other functions that change the attributes, right? So we've used rectangle mode, but there's other attribute type functions that you can use. There's 3D primitives, but we're not going to dive into that in this course. Okay? For example, if you wanted to draw a triangle, well, you would look up the reference page for triangle. You'd say, okay, what do these numbers mean? Well, in P5, a triangle is 3 points. Okay, so 1 point of the triangle, another point, and another point. So 6 numbers in total. And now you would know how to draw a triangle in code. All right. And then lastly, I just also want to emphasize again the order of operation, right? So within a block of code, lines of code are always executed from top to bottom, which means the order in which you write them makes a difference. If I move this background to the end of draw, right, I'm going to be in trouble because now what's going to happen is it's going to draw all this nice stuff, right? And then it's going to call background, which background, if you remember, doesn't change the background. It actually just paints over everything, right? That's what allows us to create animation. It erases everything with a nice solid gray, and then whoop, we go back again. Okay, so we only get to see the image we've constructed in draw by the time the draw function ends. Okay, so this gives us kind of one frame of our animation. So the order of instructions matter. There isn't necessarily a wrong or a right order. It just means that it will have different effects depending on whichever way you sequence things. For example, if I move this rectangle, I move this rectangle before the circle, right? You know what's going to happen. Now this rectangle is behind the circle because I drew it first. Okay, so whenever we draw things in the canvas, we're just drawing on top of what's already there. This is very intuitive. It behaves, much the same way that paint would behave. Okay, so the order of operations matter in when you're writing programs. Just again, there's no right or wrong. It just has different impacts. So think about that when you're creating your compositions. All right. So that really covers the basics, what I wanted to touch on this week. Now for your code exercise this week, I'm going to ask you to start to get familiar with the syntax of P5, right? So how to write commands, the basic commands that allow us to change the colors, change the different drawing shapes that are available to you. And you're going to use these to create some kind of composition over here. This is obviously nothing. This is some kind of abstract composition. For your code exercise, you're going to put a little bit more effort into it, and you're going to create a representational picture, aka a drawing that looks like something. Okay, and the only constraint that you're going to have is that drawing should be either cute or evil, one or the other. Pick one. Use as many commands as you need to create your drawing. Now, obviously, if your goal was to make a drawing of something, going about it this way using the drawing commands is probably not what you want to do in the future. You might say, well, I can do this in Illustrator a lot better. Of course, that's not the point. What we're trying to do here is really get to know some of those basic drawing commands. Right now, we don't know about variables yet. Okay, so we're just going to be specifying all of these coordinates by hand. This is going to allow us to also get familiar with the coordinate system, start to get using shift our thinking in terms of dimensions in pixels. So this is really just for you to get some practice. In the future, we're going to learn a lot more about things we can do in programs where we're not going to be specifying all of these values by hand. Of course not. This is really just, I forgot my semicolon, an exercise to get familiar with the syntax, get to know how shapes are being placed, how to set colors and so forth. And yeah, try to have some fun with it in the process. Okay. So with that, this concludes this week's video lessons. Have fun with this first code exercise, and I will see you next week.